Is your engine running rough? Check engine lights flashing at you more than the high beams on a car driving behind grandma in the passing lane of the 401? Should probably do something about that. So inside of your engine, there's a bunch of pistons that are traveling up and down. And the crankshaft is what makes those pistons travel, and it does it by rotating around. As we rotate the crankshaft, the piston is pulled down or pushed up. And each time it goes up or down, we refer to that as a stroke. So we have an intake stroke, a compression stroke, a power stroke, and an exhaust stroke. And that cycle just keeps repeating. There are 4 strokes in total, which require 720 degrees of crankshaft rotation. 4 strokes, 4-stroke cycle. Oh my God, I just got that. So right now you're saying to me, if the power stroke only occurs 25% of the time, this thing's gonna vibrate like a sundial. Well, chill out, dude. You're getting there. Most engines have more than one cylinder and more than one piston. So more than one stroke is occurring all the time. The cylinders will be distributed around the crankshaft in a sense that they will evenly distribute power pulses as the crankshaft rotates. So what we have here is the tiny 4-cylinder crankshaft of science. And if we take a look at it, we have a main axis along the center where the crankshaft is supported in the block. And then offset to either side are rod journals. And those rod journals are connected to the piston. And if we look down here, as the crankshaft rotates, maybe we have one of the cylinders at the top. It's going to pull its piston down on intake, but another one of these is pushing its piston up on compression. And so we have this cycle that all the cylinders go through 180 degrees out of phase with each other. Go intake, compression, power, exhaust, intake, compression, power, exhaust. And the order that they do that in is what's known as the firing order. Holy cow, this thing is dirty. Why didn't you wash it? Sorry. Now you're saying to me, why does my engine run so rough, smarty pants? Chill out, dude. All right, cut down your caffeine consumption. Your engine is experiencing what's known as a misfire. Normally, all of the power pulses are distributed evenly around the crankshaft as it's rotating, and the crankshaft speed is relatively constant. But when a misfire event occurs, the air-fuel mixture either isn't ignited or experiences poor ignition, and it reduces the amount of torque applied to the crankshaft during that stroke, which means the crankshaft temporarily slows down until the next functional power pulse. That's what's known as a misfire. Misfires have way tons of causes that it could be. It could be a spark problem. It could be an air problem. It could be a sensor problem. Or it could be a compression problem. Remember that stroke before the power stroke was the compression stroke. That's where we take either just air or an air-fuel mixture and we squeeze it from a volume this big down to a volume that's only about this big. That has the effect of really increasing the pressure and the temperature of that mixture. It makes it much easier to ignite. But if we have a bunch of leakage of air and fuel getting passed through the rings or a poor sealing valve, we can't compress it, we can't increase its temperature and pressure high enough to support combustion. The easiest way to tell if it's a mechanical problem, or at least set you on the right track, is to run what's called a cranking cadence test. And by doing that, we're going to disable fuel so the car won't start, but then hit the starter like we're trying to start it. And we're going to just listen to the sound it makes. If all of the cylinders are sealing properly and compressing evenly, we should hear a fairly consistent cadence as it turns over. Want to hear it again? All right. Well, that didn't sound too bad. But what about if we did have a cylinder that had no compression in it? That particular cylinder would not be squeezing its air-fuel mixture, and it just wouldn't be contributing to driving the crankshaft. And we'll actually hear that on the starter test. I mean, we're not enabling fuel, therefore it's not actually contributing to power. but the speed that the starter's rotating the engine at is going to change when it gets to that cylinder. It has no compression, it's going to have an easier time turning it. And so we'll hear that in the cadence. We'll actually hear a change in speed in one spot. And then lastly, what happens if there's no compression in any of the cylinders? Well, we're not going to hear a change in speed because, I mean, none of them are compressing anything. But we're definitely going to hear a different cadence than when the engine is running properly. Check it out. So that's it. That's the cranking cadence test. Super fast test that gives us a lot of information on what's happening inside that engine mechanically. And we can do that in a couple minutes. Now, we do need to put the engine into clear flood mode, or we have to disable fuel pump, fuel injector, something like that. We don't want to wash the cylinder walls out because we're just spraying fuel into that thing, not burning it. You do have to follow that precaution. But man, what a quick test to get such a large amount of information. If we do hear a change in cadence during that cranking, we've got a mechanical problem. Let's chase it down. If we don't hear a change in cadence, I'm looking at one of these, maybe more than one of these. All right, I'm going to do my primary and my secondary diagnostics, and we're going to get to the cause of the problem. So, that's it for me. Thanks for watching this video, and we'll see you next time.